Good afternoon, students. Today we are going to discuss the applications of prime factorization. Today we are going to discuss the applications of prime factorization. Today's class we are going to discuss about least common multiples and greatest common factor. We are going to discuss least common multiple and greatest common factor. This we will write this as LCM. We call it as LCM in short. And this we call it as GCF. We call it as GCF. What is this, teacher? For example, I am going to take two numbers. I am going to take 24 and I am going to take 30. I am going to take two numbers 24 and 30. I am going to find the factors. I am going to find the factors of 24. I am going to find the factors of 30. I am going to find the factors of 24 and I am going to find the factors of 30. What is the meaning of factor? That divides, isn't it? So 1 divides 24. 24 divided by 2, 12. 24 divided by 3, 8. 24 divided by 4, 6. We cannot divide by 5. 24 divided by 6, 4. 24 divided by 8, 3. 24 divided by 12 and 24 divided by 24. So the factors of 24 are 1, 2, 3, 4, 6, 8, 12 and 24. In the same idea, I am going to find the factors of 30. The same idea, I am going to find the factors of 30. What are all the factors? 30 divided by 1. 30 divided by 2, 15. 30 divided by 3, 10. We cannot divide by 4. 30 divided by 5, 6. 30 divided by 6, 5. Then 10, 15 and 30. Now, when we check this, these are all the factors. Now, we are going to define what is the meaning of greatest common factor. We are going to define the meaning of greatest common factor. When I check here, I can find some common factors. 1 is a common factor. 2 is a common factor. 3 is a common factor. And 6 is a common factor. So in this idea, when we are talking about the greatest, the meaning of greatest is nothing but I am going to take the big number. What is the highest number here? 6. So the GCF is 6. So the greatest common factor for 24 and 30 is 6. The greatest common factor for 24 and 30 is 6. In the same idea, we can find the multiples. We can find the multiples for 24. 24 multiply 1, 24 multiply 2, 24 multiply 3 and so on. The same idea 30 multiply 4 and so on. And then we can find the least common multiple. We can find the least common multiple. In this class, we are going to discuss some samples. See, for example, find the LCM and GCF. Find the LCM, the least common multiple LCM, and GCF, greatest common factors of 360. I am going to take two numbers for the first example and 2700. I am going to take 360 and 2700. What we have to do now? See here, for finding this LCM and GCF, we are going to apply the prime factorization. We are going to apply the prime factorization. Why? Because that will be the easiest way. Now, the prime factorization, I am going to take 360 and I am going to find the prime factors. What are all the prime factors? That means I am going to take the number and I am going to divide by 2. Isn't it? The least number 2. When we divide by 2, 360 divided by 2, this is 180. Again I am going to divide by 2. So this is 90. Again I am going to divide by 2. This is 45. 45 we cannot divide by 2, so we can divide by 3. This is 15. Again 15 we can divide by 3. This is 5. 5 when we divide, this is 1. So the prime factorization of 360 is nothing but I am having 2 multiply 2 multiply 2, 3 multiply 3, 5 multiply 1. Isn't it? So how I can write this? This is 2 3 times, 3 2 times, and 5 power 1 time. Isn't it? 2 3 times 2 power 3, 3 2 times 3 power 2, 5 1 time 5 power 1. In the same idea, I am going to take the next number. What is the next number? 2700. 2700. I am going to divide by 2. I am going to divide by 2. When we divide by 2, 2700 divided by 2, this is 1000 1 time. This is 3 times 6. This is 5 times 1 3 5 0. Isn't it? Again, this we can divide by 2. So this is 600. This is 15, 7, 5, 675. This we cannot divide by 2, so I am going to check the next prime number. The next prime number is 3. When we divide by 3, what will be the answer of this? Is 225. Again, this we can divide by 3, isn't it? So when we divide by 3, this is 75. Again, I am going to divide this number by 3. This is 25. This we can divide by 5, 5, 5, 1. So I can write this 2700 in prime factors. This is 2 power 2, 3 power 3, 5 power 2. Isn't it? We can write this 2700 in the prime factors of 2 power 2, 3 power 3 and 5 power 2. Now we are going to find LCM, least common multiple. Least common multiple. You know that very well. Multiple, that means that is the bigger number. So I am going to check the factors. I am going to check the prime factors. For LCM, we are going to take the highest power. I am going to take the highest power. What is the meaning of this? I am going to check here. I am having 2 power 3. Here I am having 2 power 2. What is the highest power? 2 power 3. Here I am going to check 3 power 2, 3 power 3. So highest power is 3 power 3. Here I am having 5 power 1, 5 power 2. So 5 power 2 is the highest power. So for least common multiple for LCM, we are going to take the highest power. And when we go for GCF, we will take the opposite. We are going to take the lowest power. We are going to take the lowest power. Now I am going to simplify this. What is 2 power 3? This is 8. 3 power 3, 27. 5 power 2, 25. So I am going to multiply this. So this is 25, 8, 200, 5,400. 5,400. Now I am going to find GCF. I am going to find GCF, greatest common factor. We are going to find GCF, greatest common factor. Here I am going to take the smallest power, or I am going to take the least power. I am going to take the least power. When I check here, I am having 2 power 3, 2 power 2. The least power is 2 power 2. 3 power 2, 3 power 3, the least power is 3 power 2. 5 power 1, 5 power 2, the least power is 5 power 1. So I am going to multiply, this is 4, multiply 9, multiply 5. So this is 20 into 9, this is 180. This is 180. So the basic principle for finding least common multiple and greatest common factor, we are going to find the prime factorization of the number. We are going to find the prime factorization of the number. And then for the least common multiple, we are going to take the highest power. For least common multiple, we are going to take the highest power. For greatest common factor, we are going to take the least power. We are going to take the least power. So this is the basic idea for finding LCM and GCF. This is the basic idea for finding LCM and GCF.